Hi everyone, my name is Ryan Booz. I'm a developer advocate here with Timescale. And for Timescale Tuesday this week, I'd like to continue on from where I was last week with part 2 of the analytical functions first and last, something we provide with TimescaleDB that you really don't get in many other, if any, other databases within the ecosystem of time series data for these specific use cases. So what I showed last week, and I'm just going to go right to SQL this week. What I showed last week was one of the conversations we were having internally. And it was just kind of a question of, what if a user was looking at their hypertable data and they wanted to get the highest value of something for every bucket, let's say an hour bucket, but not just that value, they really wanted to know exactly when during that hour that the value occurred. Now, most people would start with something like this. This was a simple max query. It gets me every bucket for everything I'm measuring. And again, if you go back to last week, I'll just mention again quickly, this is a data set that's all fake data. It's kind of measuring, it's trying to measure CPU on a computer, various measures of CPU. There are 10 different values every minute for 100,000 fake computers. And that's referenced by the tag ID here. And so for every computer, I got the max usage for that hour, all right? The max of the value, the usage value for the user. And if I wanted to then pinpoint the time, I showed that you could do something maybe like a CTE. You take the exact same query and you can join it back on itself to try and get the data. And then you have to worry about the bucket that you're joining, and you only get one time value back. So you have to add to that to get the other end of the bucket that you're looking for the value and so forth. Now this worked, but quite honestly, it took 1 minute and 15 seconds, which just wasn't very performant. And this is only for 100 of those 100,000 items. So I actually went on and I made a number of other attempts. You'll see attempt number 2 here. I did something similar. I tried some partitions. I tried a lateral join. I tried something with date trunk. Now this one isn't complete. I think I played with it since then, but I was trying to do something similar with date trunk, see if I could get it. The problem is always getting an additional value, right? So when you do time bucket, you have to aggregate things. And I didn't want to aggregate the time. I wanted to get the time as well as the value. It's just more difficult than you would think. Now, this ends up being similar to what you would probably want to do, right? Rather than query the table twice. So that CTE above took the same query I got so I could get the max value, and then it joined back on itself to find that value and find the time. So that's obviously expensive. So I thought, well, hey, what if we do this? What if we, take this big long query here, this CTE, just creates an empty table with buckets of time and then the tag ID. So I can use this very quick, I'm not doing any work here. If I select this out, I just get an empty table which has every bucket for every ID. And again, this is for 100 of those. This query, it turns out, and then I do what's called lateral join. So that takes every one of these values up here. There would be 2,400 of them. There's one reading per hour, 100 devices, 2,400 rows. I join to the table to find the max within every bucket. This ends up taking more than 4 minutes. And so I still wasn't getting there. To get exactly what I wanted was hard. And so I showed then how you could take what we have these functions called first and last. And what they do is within each bucket, it sorts the data based on a column you tell us and essentially does a limit 1. It takes the first value based on that sort. Now I can only sort on one column. And so the way that it gets sorted, let's say you have duplicates. In my case, I said rather than sort by time, sort by the usage user. And so that would give me, in this case, since it's last, it would give me a descending order. If I have multiple readings per hour that all have the same exact value, I'm going to get one of them back because I can't sort by a secondary column at this point. Maybe that isn't going to fit your exact use case, but in this case, it was good enough. I could quickly get per bucket the high value and the exact time at which that value occurred, or one of the exact times, all right? So this was really close. And then I went on to show you that this was new for me. If you actually refer to the table that you're selecting from in Postgres with these functions and with others, I just never used it this way. What you get back is a representation of every column in that table that you could refer to later. And you do that by putting parentheses around the column that you reference. In this case, I said, hey, for the minimum value per hour, call that column low reading. For the highest value per hour, call it high reading. And then I can just refer to individual columns as I need to. All right. And so doing something like this gets me what looks more and more like a table. Now, at some point, I'm going to get to almost the full table again. But this is saying for every bucket, this is what's kind of cool with this. For every bucket for each computer. So for this hour, I know both the lowest CPU reading and the highest CPU reading. I also know exactly what time that reading occurred, both high and low. And I pulled out another column. I said, hey, what was the system CPU at that same time? Well, if you realize that you now have access to a lot of these columns, you can start to do some fun things with something like first and last. So I thought it'd be fun to go through a couple of ideas. I'm not saying these are, again, the best thing for your use case. You'd really have to think about your exact use case, but knowing that you're getting a range within a bucket, something that occurred at some sorted order and something that occurred at the opposite sorted order, there's some cool things you might be able to do here. So I'm going to run through a couple and then talk about continuous aggregates as maybe one other way to use some of this. So I am going to extract, so I'm going to bucket all this data based on 24 hours. So I'm going to get one value high and one value low for every day. And then I'm going to extract the hour of every day. I'm not grouping this by the bucket. So I'm going to say, hey, for these 6 or 7 days right here, what is the average hour of the day? If I take all those hours, what's the average hour of the day that each computer seems to have its highest and its lowest value? And so we're going to go ahead and do that. And so, again, is this useful or not? I don't know, but it's kind of neat that because I can get all of those out on a daily basis and then average and extract the hour and average them, I see that in general, computer one, the average hour of the day that it has its highest usage is at 1,700 hours, and the average hour it has its lowest usage for this time period was at 10. You might see that there's some computers that have really close high and low usage. Again, it's fake data, so it might not be the most realistic data, but you might find for your use case, there's something about these servers or these computers where they're bouncing around a lot and they're doing a lot of high and low work at similar points every single day. Maybe you start to graph this on a per day basis, things like that. So that's one option. You can start to do some little aggregation functions with some of this data using a tool within Postgres like extract. This becomes one of the things that we talk about always with TimescaleDB is you're using the power of Postgres and what we provide to you on top of that. And so I'm taking multiple things and mixing it together to start to maybe bring some new awareness out of the data. Maybe one thing you could say is, hey, if I'm tracking this, is this a real data? What is the span of time every day between the lowest reading and the highest reading? Maybe if it's very long, we would start to see a trend that, obviously maybe in the middle of the night, it's very low, and in the middle of the day, it's very high. But if the interval is really close together, maybe the computer's bouncing around a lot. So we can take just a simple time reading, and this is all happening very quickly. I'm doing this over 10 items right now. I could do it over more. And so, I take this is the same query we had above. All right. And now because I'm getting the whole row, I can refer to various values within that row and do regular, in this case, it's date math within Postgres to get an interval. And so, the one thing, this is actually a conversation within Postgres. There's no way to do an absolute value on an interval right now. You would have to write your own function. So, whether it's negative or positive, this is the total time between the lowest value and the highest value and the lowest value. So some of these are, more than, 12 hours apart. So they're happening at various parts of the day. Some are much closer together. You have one that's 4.5 hours apart, things like that. All right. There's one that's, an hour and a half apart. So again, just trying to say, hey, you have access to all this data now. A value that occurred that was the highest of this specific thing I was looking for, and a value that's the lowest. What about this? Now, I kept trying to think, there's all this potential. What could I do? Now, I might see the max usage of the user CPU value and the max usage of the system, and I want to get a ratio of those two. So I'm simply going to, subtract a percentage of the two to say, what is the difference between the two? And if it's not very big, so if their usages are very close and maybe the usage is high, something's going on there. The system's trying to use a lot of resource. Maybe it's a multi-CPU system and the user's using a lot of resource. And so there's a lot of contention on that computer or that server. And so again, through some math, simply using SQL and this time bucket function, I can run this query, and this is on 100 items. This is over a week, so this is for every day. I bucketed this by 24 hours. So I got the highest usage every day and the lowest usage, and when that was occurring, what was the ratio between the highest, or how much difference was there between the highest and the lowest? And so you'll see that as it would make sense, when the ratio or the difference is not very high, I get a CPU that was maybe in the middle, 50% user, 50% system. Maybe as it gets higher, I see that I have one here that has 100% usage. The difference is only 1. Now, I did that ratio. Obviously, this is on 100%, so it's always essentially going to be that mathematical difference with a little bit of precision if you want it. But this one, hey, I had 100% user usage, 100% system, so fake data. Maybe it's a multi-core system and you're measuring things differently. There's just a lot of ways you can take this data and start to do some silly math on it, right? You can start to understand things about this data that maybe you couldn't see previously. So that's one way you could do this. Let's see, I think I had one more here. Oh, one more might be this. Again, you have this high and low. And so maybe I just want to see, in this case, how many times within a day I got usage above a certain value. All right, so anytime I got a high reading above 90, how many times a day did that happen for every tag? So in this case, I don't have to rebucket it at all. I'm just doing a simple count. And this is for 100 items. It doesn't take too long, but that took a couple seconds. And I could see, because I'm ordering it, this one computer, man, it hits 90% or more numerous times in that day. So 79 times within each hour, it got that high reading. So there's a lot that you could do with that. One of the things I think is interesting, though, is that, this is fun to do, but it can get kind of expensive. So I haven't done this for any of these. I'm going to do this one query, and I'm going to take off the explain analyze. Now, I haven't talked about this a lot, but explaining the plan, if you're new to Postgres, is how you can see exactly how Postgres is going to figure out how to go get the data and do what you want it to do to produce the result that you get. And then you can pass additional values into it. So if you just do explain gives you, it's usually pretty fast. This is just the planning. It didn't actually go get any data. So this is the entire plan of what it thinks it needs to do to go get the data for you. And it can get really complex. We're not going to get into that. But if I explain analyze, that will actually run the query and give me the real plan back, what actually happened and how it actually worked. And then if I add buffers, you get a little bit more insight. So I'm going to do this, and this will take a few seconds to do this. I don't know if you remember. And it actually went and got the data. It's not displaying it to me because I told it to show me the plan instead. Now, buffers is really interesting because this is really a measure of how much data this query is reading from disk. This is a really good measure of the amount of work that the computer has to do to satisfy your query. And this factors into all kinds of things. There's actually been a push over the last number of years for buffers to be default on when you do an explain plan. It's not currently. You have to actually ask for it. What that shows you is this line in your plan. It will show it at every node. So you can see one there. That's the top node. That's the culmination of everything that happened below. And then at every node below, you'll see it will show you the buffers for what happened within that specific node of the plan. So this one query took almost 55,000 pages of data. Now, in Postgres terms, a page is 8 kilobytes. I'd have to do the math, but that's certainly many, many hundreds of megabytes of data. So it had to read a lot of data. Now, most of this was in memory. It was a shared hit. That means it could get it out of memory. It didn't need to do much. Now, because there was a sort, it had to write some to disk. There's a temp table most likely going on. So there's a number of things that had to happen there. But we can see it did a lot of work, even though it returned in about 2 seconds. So if you could reduce that work, you will probably get a more efficient query. Now, that is not always one for one. There are times where you can actually reduce buffers and have a query that runs longer. That's beyond the scope of this video. But one way you could do that, one way you might be able to reduce reads using some of these tricks with something like first and last would be to use another feature of TimescaleDB, and that is continuous aggregates. And so with continuous aggregates, I could run that exact same query that I showed earlier, right? I do first and last. I'm getting the entire row back. So now later, I might find ways that I can analyze this data that I didn't think of right now. Now, I said this before, and I'm going to say this again. This creates a pretty big materialized view. This might not be the best thing for you. If you have a table that has lots of wide columns, text data, JSON data, things like that, I probably wouldn't recommend doing this. But if you have columns that are, integers and decimals, things of, readings of small IoT data, this might be an interesting way to approach analytics, maybe even in the short term. Maybe you drop this data pretty consistently, but you have access to all the columns for when that reading happened, so you could later on think about like, oh, what was going on then? And you still have the aggregated data, so you don't have to spend that time. So I made these materialized views. We have videos on that. I did one for a day and I did one for an hour over a certain time period. And I filled those aggregates up with some data. And so now I have the exact same, I call it a ratio query, again, because it was based on 100% CPU. It's really just a difference. I should have just done that. My apologies. But now that query happened really quickly. That was 200 milliseconds. And this is even for 1,000 items. All right. I can go to, 3,000 or 4,000 items, and it's really quick. Now, if you remember up above, that query read about 55,000 pages, right? So now if I show you buffers, you see that and that was for 100 items. For 1,000 items, this continuous aggregate only reads 3,700 pages, much less data, and therefore it's much quicker to do the work. So hopefully you can see that might happen. Here's the exact same one with the counting of rows, so that you can see how many times in any given day a computer hit that value, and you'll see that's almost instantaneous, right? That was 80 milliseconds. This happens to be over a week of time, and it gives me the count for every tag, and this was 100. So let's go ahead and say, maybe 1,000. How quick does that happen? Really quickly. So I thought that would be fun to show you. You're mixing together multiple features, right? You have Postgres features like date trunc or extract. You can average some of those values once you get those out. You can do continuous aggregates on things like first and last, which might be useful later to do comparisons about what happened within a time bucket. So hopefully this is interesting and exciting, gives you something to think through. On some ways this might be useful. There's so much potential for all of the functions that we provide that hopefully you start to see some of that. So again, remember that I linked to the video from last week below if you want a little bit more discussion about what first and last is, why I used it the way I did today. Subscribe to the video, this channel, to get updates on future videos. We're doing this every week, and hopefully we're going to start to do more than one a week. We might also start to live stream some, looking at things like this and taking user questions and seeing how we can help you learn how to use TimescaleDB better. Come look at our docs. Hopefully in a few weeks, you'll see a new update to docs, and I'm really excited to show you that. And then slack.timescale.com. Come join the community. There's so much going on there, and I continue to love seeing everyone help each other. Reach out if you have questions. You can find me at Ryan Booz on Twitter, and just reach out. We'd love to help you. Have a great day. Take care.